So you're into trig now.
Yeah.
Okay. So you're solving triangles.
Yeah.
And solving a triangle is generally you solve all three angles and all three sides. And
Yeah.
they give you three pieces of information always. That's it. Notice that each one of these problems, they give you three pieces of information only.
Yeah.
And so anytime you have three pieces of information, you can generally solve a triangle. Not 100% of the time, but most of the time. Okay?
Okay.
And we have two different laws we use, the law of sines and the law of cosines to solve triangles. Now, this is the easier one.
Yep.
That says is that the sine of one angle over its opposite side is the same ratio as the sine of another angle over its opposite side. And that's what the law of sines says. Within any single triangle, this is true, that the sine of any angle divided by its opposite side is constant for all three angles. Now, let's look at number one.
Okay.
What you need in order to use the law of sines, you can't use the law of sines immediately with all problems. You're going to see when we get to number 2 and number 3 that you can't start off immediately with the law of sines. But what the law of sines requires is that you have a relationship between an angle and its opposite side. So let's straighten out any problems that you have about what the opposite side is of a triangle,
Okay.
if you have them. Okay? But that's what the law of sines says. Now, how do I get an equation out of number 1? Well, they've given me two angles and one side. Well, angle A is 92 degrees, therefore, the sine of 92 degrees divided by 15, that's the ratio I'm looking for. That
Okay.
applies to every angle in this triangle, only this triangle. Okay? Well, the only other angle I see is that one. So it's going to equal the sine of 28 degrees over its opposite side, which is little b. Okay?
Okay.
Now, you can solve for little b based on that. There is only one variable in this equation. The sine of 92 degrees is a number. The sine of 28 degrees is a number. The only variable is b. So if I cross multiply, I get b sine 92 equals 15 sine 28. And then b is equal to 15 sine 28 divided by sine 92. You have your calculator in front of you?
I don't have mine with me right now, but I have like one online, which I'm just using off my phone.
Come up with that number.
Okay. 15. 1 second.
It's going to be a number that has to be smaller, quite a bit smaller than 15. Lachlan,
Yeah.
you want to have the calculator that you're going to use when you take tests in school. That
Yeah, I don't.
calculator, that's what you want in front of you every time we have a session.
Yeah, I just don't have mine with me right now.
Well, I understand that, but you apparently are having trouble with the one you're trying to use. That's not
Yeah.
going to work. You
Okay.
need a calculator to be able to do these.
Yeah.
I could do them on my calculator, but that doesn't do you any good.
Yeah.
So where are we at? You still trying to do this?
I think I've so 15
Okay.
and divided by.
Especially in Trig,
Yeah.
you need a calculator that you're used to that you can do trig functions on.
I got negative 5.2.
Well, that can't be right, can
No.
it? Okay. In other words, it's got to be a positive number. So, type in the sine of 28 degrees.
All right.
Now, you have to make sure your calculator is in degrees and not in radians. So what'd you get when you typed sine of 28?
I got 0.27.
Okay, that's not correct. The sine of 30 is 0.5.
All right.
So you're using a calculator that is most likely in radian mode, not
Yeah.
degree mode. You need it to be in degree mode. You know how to put it in degree mode? The way you can tell is by typing the sine of 30 degrees. If you get 1/2, you're in degree mode. If you get anything else, you're not.
What do you want me to try again? Sine of 28?
Sine of 30. Just type sine of 30 and see what you get. That'll tell me whether you're in degree mode or radian mode.
I got 0.5.
Okay, you're in degree mode. Now, type the sine of 28. What do you get?
0.46.
Okay, multiply that by 15.
Yeah.
What do you get?
Um,
15 times 0.46.
I got 7.04.
And now divide that by the sine of 92. You may have to put parentheses around that. I don't know what calculator you're using, so I don't know. What I do know is that sine of 92 is very close to 1. It's going to be slightly less than 1. So the answer to this is going to be slightly more than 7.04.
I got 0.076.
All right. You're doing something wrong. 7.04 divided by the sine of 92 degrees. I will do it on my Wolfram alpha. .04 divided by the sine of 92. Oops, not the sun, the sine. And it'll tell me whether I put it in there right or not. So one thing about calculators is you want to make sure you put it in there correctly. Okay?
Yeah.
That shows you what I input. That's correct. That's what I want. The result is 7.044. So side B is 7.044. Now, does that make sense so far?
Yeah.
We have the side opposite the largest angle is 15, and we have the side opposite the smallest angle, 7.044. Yes, that makes a lot of sense. Now, we still do not have little side C or angle C. We can't hardly use the law of sines unless we have one of them. In other words, the law of sines depends on that ratio. What can I do for problem number 1? I can't solve for side C, but I can solve for angle C. What's angle C got to be equal to?
60.
Okay. Now that I have angle C, I can solve for side C using the law of sines. Tell me what I should write.
Is this the c squared equals?
No?
No.
It's the law of sines. Law of sines says this.
Oh yeah, okay. So would we do sine 92 over 15
Okay.
and then equals sine of 60 over lowercase c?
Yeah. That's only one variable. We can solve for that. I'm going to cross multiply and then divide by sine of 92. So again, you got to come up with that number.
Okay.
And I don't know how we're going to progress through the rest of these problems if you don't have a calculator that can come up with these numbers. It's absolutely worthless for me to come up with them. It does nothing for you. So you say, what kind of calculator are you using?
It's just on my phone. I don't have mine with me at the moment.
But you have a phone calculator.
Yeah.
Does it do trig functions?
I think so. It has sine, cosine.
Okay. Well, then you should be able to do this.
Okay.
Take 15 times the sine of 60 and divide it by the sine of 92. And we have a good idea where it should be. It's got to be between 7 and 15, the answer.
12.9.
Okay? I'm not going to check it. I'm just going to take your word for it. And that triangle makes sense. And in the sense that the largest side is opposite the largest angle, smallest side is opposite the smallest angle, the medium side is opposite the medium angle.
Yep.
Okay? But in any triangle, this relationship holds true. The sine of one angle opposite the side, that's a constant relationship, no matter which angle you're looking at.
Yep.
All right. That was the law of sines. That allowed us to solve that entire triangle. Sometimes you have to use the law of cosines. And there's really only two situations where you have to use the law of cosines. And that's where you have side, 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 or you have side, angle, side. Those two situations. Notice that that's what we have right there.
Yep.
We don't actually have it with number 3. We'll get to number 3 in a second. But I want to make sure we cover the law of cosines here. We do have side, side, side. We have no angles. So it would be impossible to use the law of sines on number 2.
Yep.
Because you have to have an angle and its opposite side. On number 1, we had that angle and its opposite side. So we had that relationship. We had that ratio. But we don't have that on number 2. Now, there's a law of cosines that says the following. Starts out a little bit like the Pythagorean theorem. Right there.
Yep.
Then you subtract from that. And then it's the cosine of whatever this letter is over here, the cosine of its opposite angle. And there's actually 3 laws of cosines. That's one. This is the other. Notice what's happening. Notice what I'm doing.
Yep.
Tell me what the third one should say.
C squared equals A squared plus B squared minus 2AB cosine C.
Okay. Now, depending on what information they give you, you use one of these 3. They're all basically the same. And especially when you have side, 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 which is what we have in number 2. In other words, the very first thing I need to do is solve for an angle, okay? So I could use that. I know what A, B, C, B, and C are. The only thing I don't know is angle A. So I could use number 1 to solve for angle A, or I could use number 2 to solve for angle B, or number 3 to solve for angle C. Once I've solved for one of the angles, now I'm all set, because then I can use the law of cosines. Remember that as long as you have one angle and an opposite side, then you can use the law of cosines. So I'm going to erase the bottom 2, and we're going to start by solving for angle A. So tell me what to fill in. In other words, I'm going to use this as my general formula. And here, I just want you to fill it in. I don't want you to do any math yet.
Okay.
What's A squared going to be?
So would you go 25.6 squared.
There you go. That's what I want you to tell me. Yeah.
Equals 28.7 squared plus 17.7 squared, and then minus 2 times 28.7 times 17.7 cosine A.
What's A? Oh, okay. Yep. Notice that in that equation, we only have one unknown, cosine A.
Yeah.
So all I have to do is do the arithmetic here, and I will get cosine A equals to some number, and then I'll be able to figure out angle A by taking the inverse cosine of that number. That's my plan.
Okay.
You need numbers with all of these. In other words, if ever there were anything that needs a calculator, it's when you're working on the law of sines and the law of cosines. Especially with them giving you numbers like 17.7 and 25.6. These are not numbers you want to do by hand.
Yeah.
So, can you do these on your calculator?
Yeah, probably.
Do each one. I'll just fill in the answer and then we'll go step by step.
Okay.
It's 25.6 squared.
$655.36. And then, so equals 823.69. And then plus 313.29.
Do all three of those at once.
Okay, so 2 times. $1,015.98.
Cosine of A.
Yeah.
Now add those two.
So 800. So that's 1,136.98.
Now subtract that from both sides of the equation. In other words, what is 655 minus 1136?
Minus 481.6.
Now that's going to be equal to, right?
Yeah, why don't you do it on the other side though?
I did. In other words, I took the sum of those two numbers and moved them to the left side.
Okay.
I just don't write it. In other words, it causes that to disappear. You understand?
Yeah.
Okay. So now I still have to isolate that. I cannot solve this until I can isolate cosine of A. So what's the next step?
Is this the negative cosine part?
No, all you need to do is solve this algebraically. I've got a coefficient in front of my cosine of A. How do I get rid of that coefficient?
You add 1,050?
No, that coefficient is currently a multiplier.
Oh, do you multiply?
And divide. You always do the opposite. When you are solving algebra equations, and you're trying to get rid of something to isolate a variable, then you do the opposite of what that thing is currently doing. In other words, I had 1136 adding to both sides, so I subtracted it from both sides. Now I've got 1015 as a multiplier, so let's divide by 1015, and that will bring me down to cosine of A. So what is this number on the left?
Negative 0.47
Should it be negative?
or positive?
So, how do I solve for A? Once I get cosine of A equals some number, how do I get A? Remember, my goal here is I want to solve for that angle.
Yep.
So I'm almost there. I can do it now. Just asking you how to do it.
Do you just put in 40.47 cosine?
No, you do inverse cosine. In other words, when you're solving for angles, you use inverse trig functions. When you're solving for ratios, you use trig functions of angles. In other words, over here on the left, let me just point out something. I take the sine of 30 degrees to get 1/2, okay?
Yeah.
By definition, what that means is the inverse sine of 1/2 equals 30 degrees. So these are inverse relationships. You take the sine of an angle to get a ratio, but you take the inverse sine of a ratio to get an angle. Well, we're trying to solve for an angle here.
Okay.
I got to take the inverse cosine of 0.47. Can you do that on your calculator?
Is it 1.1?
Don't know.
I'm not sure.
I
I'll
don't
make sure.
think it is 1.1. That's an awful small angle. You need to take the inverse cosine of 0.47. That's going to give you your answer. Arc cosine, same thing. All right, when I take the inverse cosine of 0.47, I get 1.08 also, which means I am not in degrees, I am in radians. And I am on a calculator that's, I gotta remember how to switch it to degrees. I gotta go to settings. Wow. use my phone. I have a calculator on my phone. The calculator on my phone just expired. Maybe I can still do it here. Shift inverse cosine. All clear. Shift inverse. That's the wrong key. Shift inverse cosine. I've never tried using this calculator before. Let me see if I can just do sine of 30. No, this calculator doesn't work. Okay. Can't use that calculator. Let me use the calculator that I have on my computer. Another word for inverse cosine is arc cosine. And this result is, notice that it gives me my result in both radians and degrees.
Yep.
And we were getting radians. Both of our calculators were in radians. I don't know how yours got in radians. I thought we tested it and you discovered you were in degrees. But clearly you were not if you're getting 1.08. That is the same as 61.97 degrees. So that means an angle A is 61.97 degrees. That's what we just calculated.
Yep.
Using the law of cosines. You saw how complicated it was. It's much harder to use the law of cosines than it is the law of sines. But you have to use the law of sines in every single problem. It's just there's certain kinds of triangles where you have to start out with the law of cosines. Once you've started out with the law of cosines, then you switch to the law of sines. Notice what we have now. We have an angle, and we have its opposite side. So now I can use the law of sines. Tell me an equation I can write to calculate angle C.
So
Using the law of sines.
Sine 61.97 over would it just be 25.6?
It's the opposite side.
And then equals sine 17.7.
No, you're always taking signs of angles. You're not taking signs of sides.
Oh, so just sine C over 17.7.
Okay. Now, if we do the math, we'll figure out what C is. Once we have angle C, the only part to solve, well, that's all they really wanted you to solve was angle C. So we did. We solved for it. Probably could have done it in one step. When I see these kind of problems, I automatically assume they want you to solve the whole triangle. And when you solve a triangle, you have to solve for all three sides, all three angles. In this particular problem, they said solve for angle C to begin with. So I should have probably used this formula for the law of sines. Notice that had I used the bottom one, I would have immediately solved for C. In other words, I knew what that was, I knew what that was, I know what that is, I know what that is, I know what that is. The only variable is going to be that. I can solve for C. Then I'd be done with the problem. In other words, I could actually answer this question using just the law of cosines. I can't solve the whole triangle using just the law of cosines, but I can solve for angle C using the exact same method we used, only we solved for angle A. And if we'd have used this formula, we would have solved for angle C. All right. Number 3.
Wait, so because I don't have my calculator and this is kind of annoying, I can send you the next page of the packet, which is its equations, which is another thing we can work on. If you just want to do that, it'd make things easier.
Well, go ahead and send it to me. Let me take a look. It is true that there's almost nothing I can think of that needs a calculator more than these.
All right, it was sent.
However, you do need to cover this stuff.
Yeah.
It's so odd that you're getting combinations of these problems. Usually when somebody studies trig, they stay in trig for a whole semester. They don't jump back and forth between algebra and trig. But that's fine. Let's do number 7.
Okay.
First step.
Should you minus the 6?
Okay. Next step.
Should you divide by 3?
Next step.
Square root it.
Okay. So the next line, the square root of the left side is that. It's the square root of the right side.
Equals 4.
Always plus or minus.
Oh, yeah, plus or minus 4.
And the only thing I can say is that whenever you are solving an algebraic equation by taking the square root of both sides, which is what you did, always, always, always begin your answer with the words plus or minus. I don't know how to emphasize it, and I know that 90% of my students forget the plus or minus. I just don't know a way to get you to remember it. But I wish they had a song, like the ABC song.
Yeah.
But they don't. So now we got x plus 4 equals plus or minus 4. So x equals, I'm going to move this 4 on the left to the right, put it in front. Now tell me the 2 different answers there are for x.
X equals minus 8.
It's one answer.
And x equals 0.
That's using that one. Now do that one.
X equals 0.
That's how you do that. Now, number 8, let's go through the principle here. What's that mean? Two things.
X.
When I say that means two things, I mean I want you to write two different equations.
X equals 10 and X equals negative 10.
Okay, that's the way you handle absolute value. So now let's handle this. So on number 8, I got to get to where I can isolate that. Once I get that equal to some number, I'll be able to go further. So let's go through the steps. What's my first step?
Add 2.
What's my next step after that?
Multiply, divide by half.
Okay, which is the same as multiplying by 2.
Okay.
So what's that going to give me is x minus 7 equals 11 times 2, which is 22. Now, that's my starting spot. So that, by starting spot, I mean at this point, I can put that into two equations. What are they?
So x minus 7 equals
That's always the first part. The first equation is always exactly what you're looking at without the absolute value signs.
okay.
What's the second equation going to say?
Would it be negative 22 then?
Yeah, it's easy. Okay. Now, the reason I wrote them horizontally is because I want to solve them vertically. So I've got two different answers I'm going to get. What's the first answer?
X equals 15.
29. I got to add 7 to both sides.
Oh, yeah. X equals
Remember that when you have something affecting what we're trying to isolate, you got to do the opposite of it. You're not going to subtract 7 from both sides. You're going to add 7 because 7 is currently being subtracted. So you got to add 7 to both sides. So that's 29. Or what?
X equals negative 15.
There's your two solutions. And with absolute value problems, you almost always have two solutions. They're a lot like quadratics. Quadratics almost always have two solutions also. Now, whenever you get two solutions, it's always possible that one of those solutions could be what they call extraneous, which means not correct.
Okay.
And there are certain types of equations that tend to produce these extraneous solutions. One is absolute value equations, and the other is where you see a radical sign. Okay? So I definitely want to test both of these equations to make sure that it works. Okay? I don't need to test so much on number 7. We got two solutions on number 7, but those aren't the kind of problems that give you an extraneous solution. These are, but let's test it. If I plug in x29, does that work?
No.
Yeah, it does. 29 minus 7 is 22. Half of 22 is 11. 11 minus 2 is 9.
Yeah, it works.
So it works. Okay. Does the other one work? 15 minus 7. What is that?
That's minus 15. So it's minus 22.
What's the absolute value of minus 22?
Would it be positive 22?
Yeah, the absolute value of any number is always the positive.
Yeah.
The absolute value of minus 100 is 100. The absolute value of 100 is also 100. So the fact I get minus 22 means that the second solution also works, because I know that that's going to be 22. Half of 22 is 11. 11 minus 2 is 9. So both solutions work here. Now, maybe they just didn't give you any problems where they both don't work, but I'll bet one of these, they both don't work. All right. Again, when you have a problem like this, I want to isolate that. Because once I isolate that, then I can square both sides and get rid of the radical sign. But I can't get rid of the radical sign until I isolate it. So what's my first step?
Subtract 6.
It's my second step.
And then divide by negative 2.
So I get square root of 3x plus 1 equals what? What's minus 10 divided by minus 2?
5.
Now what? Now I got it the way I want it. I got this isolated.
Do you square it?
Okay. If I square the left, I get this. If I square the right, I get that. Now I take away 1. I get that. And I get x equal 8. Well, usually when you only get one solution, it's going to work. In other words, where you have extraneous solutions is when you get two solutions. If you get one solution, it's most likely going to work. If I plug in 8, then I get minus 2 times the square root of 25 plus 6. Does that equal minus 4? Well, square root of 25 is plus 5. So that's minus 10 plus 6 equals minus 4. Yes, it works just fine. And I don't really feel like it's worth the time spent. If you only get one solution, it's going to work 99% of the time.
Okay.
So you don't need to check it. Let's do number 10. Hopefully we'll run into one here where, usually you have to have a couple of square root signs, a couple of radical signs to get an extraneous solution. Let's just do number 10 normally. First step.
Would you multiply by 4?
Second step.
You're going to divide it by 5?
Always take care of numbers that are being added or subtracted first.
Oh, so add 8?
If I divide by 5, I got to divide that 8 by 5.
Yep.
So I don't want to divide by 5 until I get that 8 on the other side.
So add 8. So then 5 to the square root of 2x equals 20.
Now you can divide by 5.
Yep.
Now?
And now do you square it?
So x equals 8. And you'll find that if I substitute 8, I get square root of 16 is 4. 5 times 4 is 20. Minus 8 is 12. 12 divided by 4 is 3. So again, when I only get one solution, not so necessary to go through and prove that it's correct.
Okay.
Maybe they'll give you one, maybe they won't, where it's probably these. When you have to take square roots of both sides, that's also a possible, because you get two solutions. Whenever you get two solutions and there's anything funny looking in the original equation, make sure you got to check both solutions. This is my first step on number 11.
Would you subtract 24?
Leaving what? What's left on the right side?
Minus, and then parentheses, 2 minus x squared.
Next step?
Would you add x?
I would divide by, again, I've got a multiplier here of -1.
Okay.
I can't take the square root of both sides until I get that all by itself.
All right.
So I got to get rid of that negative sign. Well,
So add.
no, I'm going to divide. That right now, that's a multiplier. I need to divide by -1. That turns that into 8 and gets rid of that negative sign. So basically, I had a negative sign multiplying both sides. I could just cancel them out. Now what?
Do you square root it?
Okay, giving.
Um,
That leaves that on the right side for sure. What's the left side?
would it be square root of 2 and square root of 4?
Well, you're not wrong. Let's start out simple. What do I have to start my words with whenever I take the square root of both sides?
Plus minus.
Square root of 8. That's our starting spot. In other words, I took the square root of the right side, giving me 2 minus x. And I took the square root of the left side, giving me plus or minus square root of 8. Now, square root of 8 can be written 2 square root of 2, which is what you were trying to say when you said square root of 4 times square root of 2.
Yeah.
Okay, keep going.
Are you supposed to get rid of the 2 now?
I got to come down to x equals something. It's the only way you solve an equation. It's your final step, always has to be x equals something.
So should you subtract the 2?
Good. So I'm going to put that subtraction on the left, just because that is a more typical way to write that. Now what? I've almost solved for x. I got minus x. How can I turn that into x?
Is this one a multiplier?
Well, I can multiply by -1 or I can divide by -1. Either one gets rid of the negative sign.
So divide by -1?
Yeah. And that gives me an x equals, this -2 turns into +2. And believe it or not, it doesn't really do anything to the plus or minus.
Yeah.
It turns it into minus or plus, but that's the same thing. So there is my answer. Give me my 2 answers, because that's 2 answers written as one. I want to make sure you know both specific answers.
So x equals 2 plus minus 2 square root of 2?
No, the first answer is the plus.
Okay, yeah, 2 plus 2 to the square root of 2.
Second answer is the minus.
Yeah.
That's what plus minus means when you see it, is that there are 2 answers, one of which you use the plus sign, the other of which you use the minus sign. And these are 2 different numbers by a lot. One's positive, one's actually negative. Okay. Now, not going to plug those in and check just because there's a lot of math. We don't have time to do that much math, arithmetic. But I suspect both of those work. Mainly because when you square it, the negative answer, no, you know, I bet both of them don't work now that I think about it. Since we have 5 minutes, let's test both answers.
Okay.
The first thing I got to do is plug in the first one. So I got 2 minus, in parentheses, 2 plus 2 square root of 2. That's my first answer. Squaring that, subtracting it from 24, is that equal to 16? Well, I got to remove the inner set of parentheses. Always start from the inside out. Well, when I remove that inner set, that becomes that, and that becomes that. The 2's cancel, and I'm left with minus 2 square root of 2. When I square that, I get 8. 24 minus 8 equals 16. That answer works.
Yep.
Now, the other answer was 2 minus 2 minus 2 square root of 2. That was the other answer. And when I remove those parentheses, I get 2 minus 2 plus 2 square root of 2. Well, the 2's still cancel. And when I square that, I still get 8.
Yeah.
So both answers work.
Mm-hmm.
Looks like maybe they're not going to give us one where both answers don't work. Lachlan, that's a good place to stop. Let's stop at 11.
Yeah.
And I will talk to you probably next week.
All right. Thank you.
All right. Bye-bye. Make sure you have your calculator next week.